This video is concerned with product design and process selection. It's one of a few videos on this topic that are made available elsewhere in the module and indeed on the course. And you should try to look these up and make your own notes. Stop the video, rewind, make your notes and do some research into the area to pad out your understanding. But essentially what we're doing here is we're linking product design and process selection, the process of making the product, the type of processes. We're trying to link those to the product design. Product design is the process of defining all of the company's product characteristics. So product design is looking at trying to define the company's product characteristics. What exactly are the products? What is involved in their design? What are the components? How are they made? It's trying to get an accurate representation of the company's products. Product design must support product manufacturability, the ease with which a product can be made. So the product design should be the product should be designed in such a way as to make it easy for the company to manufacture the product. It shouldn't be unnecessarily complex or unnecessarily complicated in terms of its functionality, in terms of its design. It should be precise to what the customer requirements are, but not overdone. It should be enough to meet customer requirements, but additional complexity leads to additional costs, and complications in manufacturing can lead to breakdowns. It can lead to slow production for all sorts of reasons. Getting the components to insert into the product, the assembly process, the manufacturing process, the distribution process, all of it should be designed in such a way as to make manufacturing possible, and indeed it should make it easy if possible. Product design defines a product's characteristics in terms of appearance, materials, dimensions, tolerances and performance standards. When we think of a product, we think of appearance. We also should think of the materials that go to make it up and its dimensions. What size is it? What tolerances? How does it fit together? Is it well made? And how long will it last? What are its performance standards? And how will it behave under stress and under different conditions of use? So we think of design in these terms. Process selection is the development of the process necessary to produce the designed product. So having got a design for the product and having been reassured by the marketing department that this is what the customer wants, the company may decide to go ahead and produce this product. They must now design processes, manufacturing processes, assembly processes, all sorts of processes within the organization that all enable the production to take place. And there clearly is a linkage between the complexity of the product and the complexity of the production processes. Service design is unique in that the service and entire service concept are being designed. So when we think of service design, it may be different from manufacturing. Manufacturing, we're thinking of components and the engineering concepts, the design engineering type concepts that we go through to make the product. But with a service, we generally are thinking more holistically. We're thinking of the whole service. We're thinking of what needs to be done to provide the service, but we're thinking about how to deliver the service almost in its entirety, all at one go. An example, let's say an accountant is employed to do a company's accounts for taxation purposes. Well, the accountant will be supplied with the various information, the required information, and the accountant will set about getting the information into a standard format, and will then do some calculations on how much tax is got to be paid. And so the accountant will be looking at the information in total. It will be looking at all of the requirements, and in a sense, although there is a sequential process doing one piece of calculation before the other, it is one task, completing the accounts. Making a manufactured product may mean getting deliveries. That's one task. Getting the deliveries into the stores. That's two tasks. Getting the components and the various raw materials out of the stores. That's another task. Processing them, getting them onto the machines and tooling up the machines. Another task. And so on and so on. Whereas with the service one, it was delivering the information to the accountant, and the accountant then sets about delivering that service. We must define both the service and the concept. With a service type product, then we must define the service and the concept. What is the concept of the service? What is the service itself? What does it do? What will the service do? And how do we think of the service? And how do the suppliers of the service think about the service? With physical elements, we think of the aesthetics and the psychological benefits, the promptness, the friendliness, and the ambience. These are the physical elements, perhaps, of a service. We go to the accountant's office. We look at the office itself. It may be symptomatic of the type of person this is. If the office is very untidy, we may not have a lot of confidence in the accountant. If the office is very futuristic and well laid out and designed and looks efficient, it may signal up a different view of the accountant. Product and service design must match the needs and preferences of the target customer group. Whatever's been produced, be it a product or a service, it must address some need, and that need should have been identified by the marketing department. The marketing director should be the one who's championing the production of this product or of this service, because he or she has seen evidence or has got a feeling that there is strong support within the market for such a product. And that's where the idea really originates. Idea development. All products begin with an idea, whether from customers. Customers might have an idea about a product. Customers might suggest that they would like to see a product that will have the following functionality, a product that will do the following things. So the idea for a product may come from the customers. It may come from competitors. Competitors may be working on all sorts of ideas and bringing out new products and trying to influence the market and lead the market. Products may come from product ideas may come from suppliers who simply recommend why can't the raw material be used in this particular way as opposed to that way? Why can't the components be reconfigured and produce this extra item or this new product? So suppliers may come up with ideas. It could also be reverse engineering, buying a competitor's product and then disassembling it, looking at it, finding out how it works, trying to cost it, and then seeing what improvements can be made to the product, and then launching a similar product, perhaps with some innovation, some changes, which will, in a sense, outcompete the original. But reverse engineering, that's quite common. Idea development selection affects the product quality. So when we have ideas about products and how to make products or how to innovate products, it may impinge on product quality, and it may have a quality dimension. How easy is it to make a product of quality, and how easy is it to maintain quality during production of such a product? Clearly, product cost will be of primary concern. It must be the case that the person coming up with the ideas tempers the ideas with some understanding of what customers will pay and what the likely size of the market is going to be. How popular will the product be? A new idea might be a great idea to the person with the idea, but not such a great idea to customers who will be asked to pay for it. So customers must have a satisfaction from getting this product. They must want the product. And overall manufacturability, the ease to which the product can be made. If it's difficult to make, it's going to be high cost, and it's going to be a problem to make it. There's going to be lots of perhaps machine breakdowns or issues with the operators who are disgruntled by what's happening, or they don't like making this particular product because of its features. Perhaps it's extremely boring and extremely repetitive, or some issue. So to what extent can it be manufactured, and can it be manufactured cheaply? Say idea development. Someone thinks of a need and a product service to satisfy the need. So we have customers, marketing, engineering, competitors, benchmarking, reverse engineering. We have all these sources of ideas. And out of all of this, someone within the business must select an idea, must select one that is particularly feasible. It can be done, and it will be profitable. So it's a question of looking at all the various sources of information to see if one of them can be selected. So it might select customers as the ones who have the best ideas. But it could be marketing, who are looking at the existing products in the market, looking at what customers think about the existing products, and have come up with a different design. Step 2, product screening. Every business needs a formal structured evaluation process. Fit with facility and labour skills, size of market, contribution margins, break-even analysis, return on sales. There's got to be some sort of screening. There's got to be some sort of critique of the whole process. The management need to look at the ideas, to see what the opportunities are, to see how realistic the assumptions are, and see if it's worthwhile carrying on with the product. Look at the technical specifications, look at the preliminary designs and testing, and look at the specifications and try and prototype the product and start testing it, prototyping it, see what customers think about it. Perhaps form focus groups and involve people from the shop floor and people from management, and try and find out what are the issues. Are there any improvements that can be made before it's launched? And then the final design. It's based on test results, facility, equipment, materials, labour and skills, suppliers. So the final design must take into account all of these. And overall, there should be some element of entrepreneurial thinking, that this is a good idea, this is one that succeeds, there is a clear market niche, customers are interested, research shows that customers would be interested, there is a gap in the market, the competitors are not tooled up to make this product. So this type of analysis should be undertaken, but it should be undertaken realistically and critically, not biased in the sense that someone had an idea and now they want to see the idea launched. Just because somebody has an idea doesn't mean the company should launch the idea. The company should be very circumspect and be careful about what precisely the size of the market is, what are the attributes of the market, what price can be charged, what are the competitors working on currently. There should be a very, very clear understanding that there are issues, and issues that need to be considered in great detail before the product is launched. The factors impacting on product design, well, it must be designed for manufacturing in the sense that products that are not easily manufactured are going to be expensive and complicated and probably not worth taking on board. So it's necessary to ensure that the design is feasible. It can be done, and it can perhaps be done given the existing configuration of capital, labour skills, space in the organisation. So it needs to fit in. There need to be guidelines, and the guidelines should have flow charts and should have clear directions. Problems should be anticipated before they arise, and solutions written in the event of this type of failure. This is the way forward and this is what to do. So not to have people thinking when a breakdown occurs, thinking while the machine stands idle, because that is a waste of resource. It's a waste of labour time, it's a waste of capital time. The capital is not being used. The building in which the capital is located is not being used. So the problem which causes the capital to stop, the machine to stop, that should have been anticipated and solutions found before it happened. So in the event of failure, there is a place to go, a knowledge base to go that will have solutions. The ideal way to do it is to have simplified product. The problem with simplification is that it's easily copied by competitors. And in a globalized world, it may be that producers who don't have the same cost structures overseas will be able to swamp the market with cheap products based on this design. So on the one hand, keeping the product simple is a good idea. On the other hand, it doesn't offer much of a barrier to entry, and competitors will come in. If it's standardized, then it may be possible to cut costs by having specialized machines, specialized tooling on the machines, specialized labor, and there's a faster throughput of products because it's standardized. If possible, parts should be designed for multiple applications. That's the clever thing to do, to have a part that will fit into different applications so that the part can be produced in mass, it can be produced in volume and put into store and then taken out and used in different applications to make different products, but using common parts. That is an ideal solution. Try to use modular design. Try to build the product in parts if possible. And the final assembly stage, bolt all of the parts together. That would give more control, and it's easier to see the product emerge in that fashion. If one of the lines making one of the components in this modular design, if one of the lines has problems or it breaks down, the other ones are still producing. So the whole product hasn't stopped. And when the line comes back on, then some facility to catch up may be implemented, and the final assembly will not be altered or put out too much as a consequence of the machine failure. Try to simplify operations if possible as well. Simplifying operations means faster production, easier production, and there's not too much handling of the materials. It's possible with larger and more complex machines to have some sort of automation built in. It depends on the size of the project, the complexity of the project, and so on. But there may be some opportunities for automation which will simplify the routines and make life easier for the operators. There are factors in the product life cycle that influence the choice of processes and also the product design. Life cycle stages are introduction, growth, maturity, and decline. These are covered in other videos elsewhere, but introduction, growth, maturity, and decline. Facility and process investment depends on the life cycle. There's a typical representation of the product life cycle. Sales on the vertical axis, time on the horizontal axis. We have development, introduction, growth, maturity, and then the decline of the product. Well, in the very early stages, at the introductory stage, for example, it may be the case that production is limited while the item is, in a sense, being market tested. It's been introduced. But later on, if it's successful, they'll go through the growth stage. And the growth stage means more volume, more output, and different production systems, perhaps with more automation, specialist equipment, rapid output of the product, depending on the scale of the market, depending on the underlying assumptions being met. But then it enters maturity and starts to taper off, and perhaps then there's a cutting back of the volume production, cutting it back because there is now going to be less sales, and it cuts it back, reduces it down, and eventually the product's in decline, and now they're stepping backwards in terms of the technology. Perhaps the machines that were used to manufacture this will be switched over to make something new, something different. And this product will become less obvious on the shop floor. This product will be produced from time to time to meet declining demand. There's also concurrent engineering. Well, the so-called over-the-wall sequential design processes should not be used. Ideally, that was a great idea of the past. We make the product in sequential steps, and even though I say it should not be used, it still is widely used. Certainly, some stages of production must go before others. But as an overall philosophy, there should not be commitment to sequential processing. It should be looking at what is the best route to make this product, and to that end, commitment to one particular type may be inappropriate. Each function did its work, and then the function was passed to the next function. That's the idea of this over-the-wall type sequential design. So you have one function, then it moves on to the next function. And that's the way it sort of went. It's sequential design. It starts with a concept, and to performance specs, to design specifications and manufacturing and so on. And it's sequential. It's moving from left to right in the diagram we've got there. The current thinking is to move to concurrent engineering processes, where all the functions form a design team that develops specifications, involve customers early, solves potential problems, reduces costs, and shortens the time to market. In other words, there are teams working on the product development. These teams may be multidisciplinary. They may have engineers and accountants and marketing personnel and all sorts of people involved in the in the design stage. And what they come up with will be fed in at different stages into the development of the product, so that the design team will be generating ideas and talking to each other and bringing their perspectives into play all together. So there's no wasted effort. There's no point in the engineer designing in isolation only to find that customers don't like that particular design. So it's important that the marketing personnel are there to influence the engineer's thinking. But likewise, the engineer will temper anything the marketing people may want in terms of what is practical and what can be done, given the current configuration of capital and labour and space and so on. But it's seen now in the literature that this type of concurrent engineering process is the way to go. This is the more up-to-date thinking. So the old-fashioned sequential one, there could be problems developed anywhere along the line. There was the concept of the product, performance specifications, what they wanted, the design specifications, and when they finally got around to manufacturing it, they may find that the product was not practical. There were some issues that were not picked up, or they produced a product that the market didn't want. So concurrent engineering processes involving multidisciplinary teams are seen as more effective. Remanufacturing, well, use components of old products in the production of new ones, and this has all sorts of environmental benefits. So take the old products and take out usable parts and reuse them. Remanufacturing, it's using existing technologies, it's using existing machinery perhaps, or existing designs for components. It's using what the company has got. And as I said, there are environmental benefits. Sometimes items don't have to be produced because they were previously produced. And there are cost benefits associated with this. These items may be cheap to acquire as opposed to making them fresh and making them new, which may be costly. It tends to be good for areas like computers and televisions and cars and that sort of thing, where there can be some degree of reusage of different parts, if possible. Now, types of processes. Well, we have intermittent processes, processes used to produce a variety of products with different processing requirements in lower volume. So it's intermittent. There are different requirements from the product. It's produced in low volume. The example here is healthcare facility. It's intermittent. If you like, it starts and it stops, and it's not a continuous process. There are gaps perhaps, and it's not in high volume. So doctors are not seeing lots and lots of patients. They're seeing a certain number of patients, and they're trying to deal with the issues of those patients in the timescale they've been allotted. But it's not high volume. Repetitive processes used to produce one or a few standardized products in high volume. That's repetitive. It's where the product is highly standardized, so each one is the same, and that means specialist machinery, specialist personnel, and the machines can run fast because they're making the same product over and over and over. And that's all we're going to deal with in this session. What we've done here is we've looked at product design, some of the issues of product design, and we've talked about the approaches to the development of processes to make the products that are more up to date in terms of their thinking, the involvement of engineers and marketing people on the same committees looking into a product. No segmentation and no isolation of departments with their contributions coming in later, when perhaps their contributions will be too late. So we're talking here about process development in a modern sense, and we're talking about product design. But that's all I'm going to deal with here, so I'm going to leave it at that and say thank you for watching.